Quick recap to start on what is a surd. Okay, a surd is an irrational number which comes from square rooting a non-square number. So if I take something like the square root of 36, I get 6. Okay, that's a rational number. Okay, it's a whole number. Really nice. But if I square root something like 35, or we take a simpler one like the square root of 3, and I get 1.57, and so on, dot, dot, dot. It continues on forever. As a decimal, it's got no pattern to it. I can't write it as a fraction where both top and bottom are whole numbers. I have an irrational number. So that's what a surd is. So we want to simplify these guys today. And really what we're going to need to know to do that is our square numbers. Our first square number is 1. I'll put it up there. I'm just going to write a list down here. It's not super helpful for us to use 1 though. 1's a square number, but you'll see why it doesn't add a lot of value. So 5 squared is 25, 6 is 36, 49, 64, 81, and 100. We can go bigger than that as well, but I'll have all them up to 10 squared down the side to start with. So we are going to use the fact that a surd is actually a fractional power. That's kind of our biggest thing we use to simplify these. We don't necessarily write them that way all the time, but that's why we can do what we're about to do. So if I've got the square root of a being a number, let's say it's a whole number, a non-square number, in fact this works for any number, but for our purposes, let's say it's a non-square number. That's the same as a to the power of 1 over 2. Okay, if I had the cube root of a, that's the same as a to the power of 1 over 3, but we're not really going to use that guy for this lesson. Just a statement to go along there. So the fourth root, the fifth root, and so on would be a to the 1 over 4, 1 over 5, but we're not going to use that today. So let's take something like the square root of 10. Now, if I think about the factors of 10, the factors of 10 are 5 and 2. Or 1 and 10. We're not going to use 1 and 10 because what I want to actually look for here is prime factors. 5 and 2 are both prime numbers. So that's the square root of 10 is the square root of 5 times 2. You'll think back to one of our index laws. Okay, our index law that's something like this. If I've got a, b to the power of 2, that's the same as a squared, b squared. Okay, whatever powers are in here, I can apply this 2 to both of those. So it becomes AB times AB, or A times A times B times B, A squared, B squared. I can do the exact same thing here with my surd. Okay, I've basically got, if I've got 5 times 2 to the power of a half, that's 5 to the power of a half times 2 to the power of a half. Or another way to put it, I can split that up into root 5 times root 2. Now, in terms of actually simplifying here, that's not a whole lot of value because neither 5 nor 2 are square numbers. So that's as far as I can take this. Root 10 cannot be simplified. Okay, we are done. Okay, there is no simplifying that can be done there. But when we do find square numbers that are factors of our number, we can take this a little bit further. Let's have a look at one here. The square root of 12. So again, if we think about the factors of 12, let's pick a prime number that's a factor of 12. We could go pick 2 and 6, but neither of those are square numbers. Let's look at down our list of square numbers. 1 doesn't help us here because that just gives us 1 and 12. Yep, the 1's all well and good, but it doesn't get rid of anything for us. Okay, we can't do anything with 1. Let's pick 4 and 3. So I'm going to split that up into root 4 times 3, which becomes the root of 4 times the root of 3. Now what this means, the root of 4 now, well, the root of 4 is just 2. So the way I can write that is 2 times root 3, or the simpler way we do that, just like we do algebraically, we don't write 2 times x, we write 2x, we can write 2 root 3. And that is the simplified version of the square root of 12. So what we're looking for here is our square numbers and our prime numbers. Let's do some more examples. We've got 4 examples here. Let's have a look at simplifying these. And again, we are looking for factors of our surd that are square numbers and prime numbers. We're looking for big square numbers and small prime numbers. Let's have a look at this. So let's have a look down our list here for the square root of 18. Well, for the square root of 18, I see straight away that we can't use, one's not going to be helpful for us. I'm going to cross one off our list because it is in one of our numbers, but we're not going to really be using it. I can't use 4 because 4 is not a factor of 18, but if I go use 9, I end up with the square root of 9 times 2. That's great. I've got a really small prime number in 2, the smallest prime number, and I've got the square root of 9, a nice square number. So that becomes root 9. Now I can split this up using my fractional index that I don't need to write, but that's the property I'm using, which becomes 3 times root 2, or 3 root 2, a simpler version of the square root of 18. Go put root 18 into your calculator, or 3 root 2, 3 times root 2, you get the same thing. Let's have a look at the square root of 50 as well. Now, if I think about my factors of 50, I've got 5 and 10. Neither of those are square numbers. That's not really going to help me. Let's have a look down my list here. Okay, I can't use 4. 4 is not a factor. Neither's 9, neither's 16, but I can use 25. Okay, so if I go and think here, I've got the root of 25 multiplied by 2, which becomes root 25 by root 2. Now the root of 25 is 5, multiplied by root 2, which is 5 root 2. Okay, we're good to go. We've simplified our surd down from root 50 down to 5 root 2. Let's have a look at 400 here. So my factors of 400, let's start going. Okay, so I can use 4. 4 would be 4 times 100. Okay, that's useful. Let's have a look here because 4 is a square number. 4 times 100. That will become root 4 multiplied by root 100. Now I've actually done here, we've got 2 square numbers, which actually means that we don't have an irrational number, we've got a rational number. So if you go put root 400 in your calculator, you're going to get a whole number answer. So the root of 4 is 2, and the root of 100 is 10. So the root of 400 is just 20. Because 20 squared is 400. So that's okay. We could have avoided doing that one, but it's good for us to see that if we do in fact take 2 square numbers there, 2 square factors, we can get down to our whole number, showing that the root of 400 is in fact rational. 125 here. Look at my factors. I don't have 4, I don't have 9, I don't have 16, but I do have 25. Now 125 is 25 times 5, so I've got the root of 25 times 5. 5 is a prime number, which is a really good spot to be in, which is the root of 25 multiplied by the root of 5, or 5 root 5. It's a coincidence here that we've got 5 root 5. That's only because 125 is 25 by 5. So what we're looking for here, we go look for our factors of our number under our square root, where we're looking for big square numbers and small prime numbers. The bigger the square number, the better. I've just got 2 more examples here. I want to prove a point with both of these. Let's have a look at the square root of 48 here. All right, I'm going to start off by saying I don't have my square numbers down the side of my page, but I can say that I know that 48 is 4 times 12. I can use my first square number, I can use 2 squared. So I'm going to have the root of 4 by 12. Okay, so I can split that up into root 4 by root 12, which is 2 root 12. Awesome, we've simplified our surd, but we've actually missed something here. If I have a look at 12, I can actually simplify 12 down into root 4 by root 3, which is 2 root 3. So my end answer here would be 2 by 2 by root 3, or 4 root 3. Now we could have gotten there more quickly to start with by looking at 48 here and saying, well, that's actually 16 by 3, the root of 16 by 3, and we would have been able to get there in a couple less steps. But the end result is, if you simplify a surd and you're not sure whether you finish it, just go check the factors. If the factors are more square numbers, then you've got some more simplifying to do. If you simplify something and you end up with root 3 times root 7, you're done. Okay? If you end up with numbers that are not square, no square numbers in there, you cannot simplify any further. Okay, so it's not wrong to have done what I did to start with, but you can do it simply by looking for the biggest square number that goes in. 4 was a square number that goes in, but if you go look for the biggest square number that goes into your original surd, you're going to be able to simplify quicker. Now, if we have a look at root 30 here, let's think of the factors of 30, and I'm going to go take 5 and 6. I would normally look for square factors, but I want to show you something with 30 before we move on. I've got 5 by 6, so that I can actually split up into root 5 by root 6. I can take root 6 a little bit further. I can turn that into root 5 by root 6 is 2 times 3, so I can say root 2 times root 3. Now what I've actually done here, I've actually written 30 as a product of its primes, or split it up into its prime surds. So 30 is, the root of 30 is in fact 2 times 3 times 5. Now what do you notice about those three numbers? They're all prime, which means that none of them are square. Which is why we can't actually simplify the square root of 30. Okay? It's like me asking you to simplify 2x plus 5y. There's nothing I can do with those. Okay? Or simplify 10x over 3y. There's different ways I can write it, but there's no actual simplifying to be done here, okay? So something where I have no square numbers built into it, no square numbers as factors, there's just nothing I can simplify, okay? So if you come to something and you say, I don't think there's actually square numbers in there, I can only get to primes, well, then that's all you can do. There's no actual simplifying we can do here. I hope this has helped.